Okay, hi everyone, and welcome to my channel, Math Made Easy with Terry in 10 minutes. In the previous video, we talked about absolute values with less than or equal to inequalities. But in this video, we're going to talk about absolute values with greater than, okay? Greater than or equal to inequalities. Now, similarly, these video is going to be really similar with one or two differences, okay? I'm going to just talk about the 5 rules, similar to the less than, but the 5 rules here is going to be almost the same, except with the change in sign and in step 3, all right? All right, let's pick an example to quickly do this. So let's say we have 4x plus 1 is greater than or equal to 3. You were told to solve this. How would you solve this, okay? We have the 5 rules. Okay, 5 rules. Number 1, equate the function similar to what we did in the less than. So equate the function. Let me divide this into 2. So equate the function on the left-hand side, okay, to both the positive and negative answer. On the right-hand side. Okay, so let's say we have this one. So that means it's going to be 4x plus 1 is equal to 3, and 4x plus 1 is equal to minus 3. Okay, so as usual, you solve it. So x is going to be, you take 1 to the other side, but that will be the for step 2. So let me then jump myself ahead now. Okay, so that was the first one. So you equate it to the positive and you equate it to the what? To the negative. So the answer we had here equated to both the positive and you equate to the negative. So step 2 is you solve the equation. Okay, to find x. All right, so let's solve the equation. So we have 4x plus 1 is equal to 3. So therefore, x is going to be 3 minus 1 divided by 4, and that will give us 1 over 2. So x is equal to 1 over 2. And if you do the second one, 4x plus 1 is equal to minus 3. Therefore, x is going to be minus 3 minus 1 divided by 4. Therefore, x is going to be minus 1. That is it. Now, the third rule is that you have to then write your answer in the form of x is less than minus a and x is greater than minus a, similar to what we talked about in the introduction. So you have to now write your answer in the form of x is less than minus a and x is greater than a. Or, okay, so you have to write it, both of them. So where we know that minus a is the lowest, I think the best conjunction to use here should be and. Okay, and a is what? The highest. So that means in this answer, minus 1 is the lowest and half is the highest. So that means we're going to write x is less than minus 1 or x is greater than half. Is that making sense? So that will be the answer for that. Now, similar to the less than we solved, you can confirm by testing if 0 is part of the solution or 0 works, okay? So you can test to confirm, all right, by testing with x is equal to 0, all right? So you can test with x is equal to 0. So we have 4x plus 1. Okay. So you put 0 here. So it's going to be 4 into bracket 0 plus 1, 3. This is going to give you 1. Absolute value is greater than 3. And therefore, we have 1 is greater than 3. So 1 is never greater than 3. So therefore, 0 does not work. Then the final fifth rule is that you have to graph the function. Number 5, you have to graph the function. Okay, so you have to graph the function. So similar to what I told you, you can first start with a number line. So the value for x and the value for y we have here is x is half and minus 1. So you can say this is minus 1, this is 0, and this is half. Okay, that is it. Now to get the value for at what point will the vertex of the modulus touch the graph? What you just do, you equate the function 4x plus 1 to be equal to 0. So 4x plus 1 is equal to 0. So therefore x will be equal to minus 1 over 4. Okay, so minus 1 over 4. So you can now draw the graph now. And at the point of x is minus 1 over 4. So let's say this is 0. Then if this is minus 1 over 4, then we draw the graph like that. Okay. All right. So so this is the x-axis, this is the y-axis. So let's assume that this point is where 3 is, right? The question was for 3. X is greater than 3. So if this is 3, you draw a line to touch it. So that means on this point here, this is where it's going to be half. Okay, and at this point here is where it's going to be minus 1. So this point here is going to be minus 1. All right. So these are the two x values we've gotten here. So now, since we're looking at greater than, that means above the x-axis are the solutions. So that means anything below the x-axis is not going to be the solution. So any of this here is not going to be the what? The solution for it. That is it, and we're done. So let's pick maybe 1 or 2 examples to just round up this video. Like I said, you can try it again. Just go back. Let's play with x plus 3 is greater than 7. All right. Now you can pause the video as usual, try solve it, then come back and have a look at it. Now just go back, have a look at the rules again. Rule 1, equate both functions to both positive and negative. You solve the equation to find the x. You write the answer in the form you expect. You test and you graph it. Okay. So you can pause it, then you can come back and play it to check your answer. All right. So as usual, it's going to be x plus 3 is equal to 7. And the rule 1, x plus 3 is equal to minus 7. So you equate both to positive and negative. So x here is going to be equal to 7 minus 3, and that will give you 4. And x is going to give you minus 7 minus 3, and that will give you minus 10. So it's going to be, therefore, x is going to be less than minus 10, or x is going to be greater than 4. Okay, so that will be the answer for this. All right. Now you can show the values here. So we have 0. We can call this 4. You can call this minus 10. So you want to check as well if 0 is going to be part of the solution or works here. So we're going to check at x is equal to 0. So it's going to give you x plus 3 is greater than 7. 0 plus 3 will give you 3. So that means 3 is greater than 7. But 3 is never greater than 7. So that means 0 does not work. Okay? So 0 does not work. Now, because we now know that 0 does not work, okay, so we can also draw the curve for this. So to get the curve, you have to equate x to be equal to x plus 3 to be equal to 0, okay? So we have to equate x plus 3 to be equal to 0. So to get the vertex of where the modulus is going to touch, so we can now say x is going to be equal to minus what? 3, all right? Now you do the same thing. We draw the graph, okay? So this is the y-axis, and this is the x-axis, and this is the point 0. Our answers are minus 3. So minus 3, let's say assume minus 3 is here. Then we draw the graph like this. Anyhow you wish. Remember, we're just sketching. And if you're saying x should be equal to 4, all right? So depending any way you want to put it, if you assume here is 4, or anywhere is 4, depends on what you want to do. So, but because we're looking at 7, so if this is 7, for instance, so draw a line, okay? We draw a line all the way so we get here. So that means at this point here, the first answer we're getting here is 4. So that means this point here is going to be 4. And this point here is going to be minus what? Minus 10. Is that making sense? And that'll be the answer. But now, in this case, we're looking at greater than. So the answers we're looking at is greater in the upper part of this curve, not the lower part. So that means the lower part is not going to be part of the answer. So this part are not part of the what? Are not part of the answers. And that's how it should look like. All right. Let me just add one more. I'm tempted to add one more. So let's say we have x minus 1. Absolute value is greater than 3. The same thing. X minus 1 is equal to 3. X minus 1 is equal to minus 3. So you take x here, take 1 to the other side. X is going to be equal to 4. X, you take minus 1 there, is going to give you minus 3 plus 1, and that will give you what? Minus 2. So it's going to be x is less than minus 2, or x is greater than what? 4. And that will be the answer for that. So the same thing, you can draw it, check it on the number line. This is going to be 0. It's going to be minus 2, and this is going to be what? 4. As usual, you check with 0 to see if 0 is part of the solution. So you have x minus 1 greater than 3, 0 minus 1 greater than 3, minus 1 greater than 3, and we know 1 is not greater than 3, so 0 does not work as well. So 0 does not work. Now, because 0 does not work, then we can also finish it off by drawing the next part to equate the graph. So as usual, you have to equate this to be equal to 0 to get where the vertex is. So x minus 1 is equal to 0. So therefore, x is equal to 1. So when you draw the graph, if this is your 0, this is your 1, all right? So you have it here, and we are having it at x is equal to, y is equal to 3, and gave us 2 positive numbers. So let's assume this is the value here at y is equal to 3. So the one by the right is going to give me 4. The one by the left is going to be what? Minus 2. And so this is going to be your y-axis, and that'll be your what? Your x-axis. So that is it. And that will give you the answer for what you're looking for. All right. So that is that for that. And you can practice it and see what you see what we have. All right. You can practice and see. So from here, you can see that this is not going to be part of the what? The solution for that. All right. Okay, so I'm going to see you in the next video. If you have any questions, the next video, I'm going to solve more examples on this. And if you have any questions, feel free to let me know, and I will answer it or put it in the comment section. Okay. Thank you very much, and see you soon in the next video.